Good morning, students. Welcome for the second session. Today we are going to deal with the numericals on RLC circuits. Okay, let's observe the circuit which they have mentioned. For the circuit shown below, find total impedance, current, power factor, and power consumed by the circuit. It is of R, RL and RC circuit which connected in parallel. Okay, so now observe, this is not RLC series circuit. Okay, so what and all they have asked us to calculate: impedance, that is Z, current I, power factor cos phi, and power consumed by the P, by the circuit. Okay, observe, this circuit consists of three branches which are connected in parallel. Once you say parallel, it is we are very familiar that if you say circuit is in parallel, then we'll say voltage remains same in all the branches. Okay, voltage remains the same in all the branches. This thing we know. Alright, now we need to calculate what is I, what is Z, what is I, what is cos phi, and what is a P. Okay, how to calculate this one? This is a bit different. As I told you, this is not RLC series circuit, this is RLC, means parallel combination. So why it is different? Because cos phi, whichever you used to take it as R by Z, is not going to work for this. Okay, because of this reason we are going to make use of complex numbers. Okay, we'll express this impedance, RL series impedance, in the complex forms, even RC also in the form of complex, and then we'll calculate. Let's see how we can deal with this. Okay, now briefly we'll discuss how to tackle this numerical. Right, make sure, means as we told, these three are in parallel, so this impedance means, this one, this branch can be taken as Z1. Okay, Z1 means the first branch impedance, so this one will take as Z2, which is a second branch impedance, and this is a branch 3 impedance. Now our task is to calculate what is Z1, what is Z2 and Z3. Z2 and Z3. If you know what is Z1, Z2, Z3, then these three are in parallel. We can use the same concept how we used to do in resistors in parallel. Okay, so Z1 by ZB, which is equal to 1 by Z1 plus 1 by Z2 plus 1 by Z3. In the same way we can do it. Right, so only thing is how to calculate Z1, Z2 and Z3. What is Z1? Z1 consists of only single resistance, that is a pure resistance, so you can take directly in terms of 10 ohm. So Z2 is what? It is the R and L series circuit. What we have to do is, its impedance we have to take it. We are not going to consider it as a square root of, okay, square root of R square plus XL square. Remember, we are going to express this one in the form of complex. Therefore Z2 will be R plus J XL. R they have given for this branch 20 and XL is 0.1 Henry. But what is XL in ohms? This is in Henry, this is in ohms. So this has to be 2 pi f L. Okay, by calculating this you can substitute in this. Alright, what is Z3? It is general formula. As a general formula of RL and RC circuits you have written. Okay, just go through those formulas. R3 is equal to R minus J XC. Okay, remember this is minus J XC. I have explained why we have to take it as minus J. Okay, and here we don't know XC, so but we have a formula 1 divided by 2 pi FC. So you know frequency capacitor, substitute in this, you will get XC. So you can get Z3 also. Z1, Z2, Z3 are first branch impedance, second branch impedance and third branch impedance. Take its equivalent. Okay, so then ZP will be your total impedance. So first task can be calculated like this. Okay, second thing is, what we have to do is we need to calculate a current through it. Okay, just to observe a circuit diagram, it was R, RL and RC. So as we said, these three are in parallel, and we know that voltage remains the same in all the branches. It is 230 volt. Therefore, across this branch it will be 230 volt, across this branch it will be 230 volt, and across this also it is 230 volt. As we know, its values of 10 ohm, and it is 20, and it is 15 ohm, right? So but we know impedance of each branch. Okay, we know Z1, we know Z2, and we know Z3, right? So voltage across each branch also you know, and impedance of each branch also you know. Then can you calculate I1, I2 and I3? How? That is, V voltage remains same, V divided by Z1, V divided by Z2, and V divided by Z3. Okay, by doing this you can calculate I1, I2, I3, each branch currents. Okay, once you have calculated I1, I2, I3, what you can do is take a point P at this, and then what you can do is apply KCL at that point. Okay, at point P, if you apply KCL, then it will be, what happens, current entering will be equal to current leaving. So current entering is I, will be equal to current leaving, I1, I2, I3. So I1 plus I2 plus I3. You have calculated I1, I2, I3. So substitute, you will get a I. Second task also completed. Okay, so and then third is cos phi. Okay, we require cos phi. Cos phi is what? It is the cosine angle between voltage and current. Okay, so now what is the voltage? Voltage is supply voltage. It is of 230 volt. What they have not mentioned anything. Meaning of this one is 230 volt at an angle 0 volts. Okay, what is current? You have calculated, and you will get in the form of A at an angle B form. Okay, this is angle and this is angle. This is in terms of ampere. Voltage angle is 0, current angle is B. Okay, some after calculating some value you get. So what is cos phi then? Cos phi is cos of angle between voltage 0 minus angle of this current. So whatever you calculate, it will be cos phi. Once you calculate V, I, when you know V, I you have calculated, cos phi also you have calculated, then you can calculate P is equal to VI cos phi. Remember, while taking P, here we need to take only magnitude of this one. Okay, so magnitude of voltage is 230 volt, magnitude of current is this one, whatever you get before that angle, that is into cos phi. This will be in terms of watts. I hope you have got how to deal with this numerical. Okay, so let's solve this numerical directly by taking these values. Okay, so let's take this one. First branch is only resistance, second is 20 ohm, 0.1 Henry, and third one is 15 ohm, and capacitor is of 150 microfarad. Okay, so these three are connected in parallel across 230 volt, 50 hertz. Okay, let's calculate. As we told, first branch is Z1 is directly we can take it as 10 ohm. Okay, next second branch Z2 is equal to R plus J XL. Calculate XL first. XL is equal to 2 pi FL. So you know 2 pi is a constant term, F is 50 hertz they have mentioned, L is 0.1 Henry. Okay, calculate this value, you get 31.4. Substitute here, it is R is not this one. Okay, this branch, right? It is 20 plus J 31.4. impedance of a second branch is also in ohms. Next is Z3. which is equal to R minus J XC. We don't know XC, so XC will be 2 pi 1 divided by 2 pi FC. Okay. So make sure, as we have discussed in the previous class, it should be only in farad. So it is 150 into 10 to the power of, it is 150 into 10 to the power of minus 6 farad. Okay, let's take this 2 pi into 50 into 150 into 10 to the power of minus 6. So after doing this one, you get 21.22. Therefore it will be 15